In this session, actually, what we will discuss is about the projection of lines which are inclined to both the planes. We have seen projection of lines which is parallel to one of the plane and inclined to the other. That is inclination with other, and the line is parallel to the second one. So the line is parallel to HP and inclined at an angle to VP. That sort of things we have seen. And the line is parallel to VP and inclined at an angle to HP. That also we have seen. Now in this session, actually, what we will discuss is the line is inclined to both the planes. Then what is the condition? Actually, it is the most difficult condition in projection of lines, as well as it is from this part we have to expect the questions in the university exams, because all other parts until what we have studied till now, those were the basics which you need to understand, so that you can understand what we will be discussing in this session and the sessions afterwards. So we never expect questions from whatever we have covered till now. We will expect questions from whatever we have to cover from now onwards, or what we have to actually uncover, what we have to learn from today onwards. So that is the first topic among this one is the projection of lines which is inclined to both the planes. So let's see how the pictorial representation comes up. And this is the HP and VP. As we already know, that is HP is the horizontal plane and VP is the vertical plane. And now the line of intersection of these two planes, that constitutes the XY line, or our reference line. This XY line is also known as the reference line, because in two-dimensional drawing, when we convert this three-dimensional views into two dimensions, the reference line or the line which separates the HP from VP is the XY line. So that's why it is known as the reference line. And almost all the distances are measured from the XY line itself, because any distance which is to be measured from HP is to be measured from XY line in our orthographic views, as well as any distance which is to be measured from the vertical plane is being measured from the XY line in the case of the orthographic view. So XY line is our reference line. And now consider a line AB, and this line is inclined to both HP as well as VP. As it is evident from the figure itself, the line is inclined to both HP as well as VP. Now, if we create the front view, if we draw the front view, for front view we are looking in this direction, the direction of the red arrow. So it is and for top view we have to look from the top in the direction of the red arrow, that is from the top. So to get the front view, what we have to do is we project the endpoints of the line. That is, the point A as well as B is projected to the VP in order to get the front view. And these 2 points are marked as A dash as well as B dash. Then we join this A dash and B dash in order to get the front view, as we done in the previous cases. That is, when the line was parallel to one of the planes. The same cases we are doing it. So here is our front view, and the front view is making an angle of XY line. Making an angle of alpha with the XY line. So this line which is newly drawn, the latest line, that is this line. This line is parallel to XY line. So this angle will be equal to alpha if this front view is making the front view is making an angle of alpha with the XY line. So this is the alpha, that is the inclination of the front view with the XY line. Now here is A dash and B dash. So A dash B dash is the front view, and the front view is making an angle of alpha with the XY line. So that is the case of the front view. Now we go for the top view. So this is again we are projecting it to the HP, and the points of intersection is marked as A and B, and then we join in order to get the top view. So now the top view is making an angle of beta with the XY line. The top view is making an angle of beta. That is the apparent inclination. That is the inclination of the top view with the XY line. That is beta. So that is also there. Now this is AB. Now we join A dash and B dash with the XY line, or draw projectors, draw perpendicular projectors from XY line to A dash and B dash. Likewise, we draw perpendicular to XY line to A and B. So this is the complete projection in three-dimensional representation, or in the pictorial representation. Now, so in the right hand side also the same picture is repeated. The same picture is repeated on the right hand side also. Now, if we remove the actual line, the original line, that is the original line AB, and the corresponding lines or the related lines. So this is what is remaining. So this is the image that is formed on HP as well as the VP. Or when we remove the object, the actual object, that is the line AB, what remains is the projections on HP as well as the VP. So in HP it is the top view, and on VP it is the front view. So front view is A dash B dash and top view is AB. And the front view is making an angle of alpha with the XY line, and the top view is making an angle of beta with the XY line. So now if still this one is in 3 dimensions, because HP and VP are mutually perpendicular, so the entire thing will constitute a 3-dimensional thing. So in order to convert this into 2-dimension, what we do is we rotate HP 90 degree in the clockwise direction. So, or downward, HP 90 degree downward we rotate. So now we obtain the actual orthographic views. So here it is A dash B dash, that is the front view. This is the angle alpha, that is the inclination with the XY line. The inclination of A dash B dash with the XY line, that is here. And the XY line is here. And AB, the top view is here, and the top view is making an angle of beta degree with the XY line. So in this case, since the line is inclined to both HP and VP, none of the views are parallel to XY line. So in the previous 2 cases, that is when the line is parallel to one of the plane and inclined to the other, what we obtained is one of the views was parallel to the XY line. You might be remembering. And the other one was inclined to the XY line. Suppose if the line is parallel to HP and inclined at an angle to VP, the front view was parallel to the XY line and the top view was inclined at an angle to XY line. So when the line is parallel to HP, the front view is parallel to the XY line. So that is the way we obtained in the previous 2 cases. So, but in this case, none of the views are parallel to the XY line. So, the front view is seen on VP clearly, and the top view is on HP, and hence the HP, that is what is the top view. The top view becomes below the XY line. So this is how the arrangement will look like. And we have discussed that none of the views is parallel to the XY line, since it has inclinations to both HP as well as VP. So that is the concept. Now, both the front view and the top view are inclined to XY line, and that is the no views is parallel to the XY line. And one more thing is evident from this one, that is when the line was parallel to HP, the projection on VP was parallel to the XY line, and it has a reduced length. That is when the line had an inclination with the VP, the projection on that particular plane, that is the front view was having a reduced length. Here also, since this line is inclined to the VP, obviously the length of the front view should be reduced to a reduced length. So here also the front view is a reduced length, and here The line is inclined to HP also, not just to VP, it is inclined to HP also. So that means it has to be of a reduced length in the top view also. That is, since the line is making an angle with HP, the top view will be having a smaller length or a length which is shorter than the actual length. So that is the case. That is, both front view as well as top view are of reduced length. That is, no view shows the actual length of the line. So in this case, no view, none of the views shows the actual length. This is the length of this line, the pink line, that is AB. It is the true length. But here, in front view as well as in top view, none of the lines gives it the true length. So here, it is evident from here. See, this length, this AB is of reduced length than this one. And here also, A dash B dash is of a length which is less than this capital AB. So, none of the views, when the line is inclined to both HP and VP, none of the views will give you the true length. And in order to obtain the true length, what we should do, and if we doesn't know the length of the front view as well as the top view, how we will draw the projections? That is, when we know only the true length of the line, we cannot find out, or we doesn't know the length of the front view as well as the length of the top view. In that case, how to complete this one? That is the point of discussion here. So, sorry. So, here we have shown, or we have repeated the front view as well as top view of the line AB. The top view is small letter AB and the front view is A dash B dash. And the front view is making an angle of alpha with the XY line, and the top view is making an angle of beta with the XY line. So, is this alpha same as the inclination of this line with HP? That is one question. And is this beta same as the inclination of the line with the VP? The second question. And obviously we have found out that A dash B dash is not equal to the true length AB, and AB, small letter AB, is not equal to the true length capital AB. So that we have already found out. Now the next condition is whether alpha is equal to theta, that is the true inclination with HP, and beta equal to phi. Is it true? Actually, it is not. Actually, alpha will be a value that is greater than the theta value. That is, alpha will be always greater than, or at least equal to theta. Alpha will be equal to theta only when AB, the top view, is parallel to XY line. That is, when the line is parallel to VP, when the line becomes parallel to VP, then the top view becomes parallel to the XY line. Then the front view will give you the true length as well as the true inclination. That we have already seen in the case of the line which is parallel to the VP and inclined at an angle to HP. In that case, the front view gave you the true inclination as well as the true length. So here alpha will be greater than phi, theta. Alpha will be greater than theta. And beta will be greater than or equal to phi. That is, the true inclination with the VP is denoted by phi, and beta is the apparent inclination in the top view. We know we call the beta value as apparent inclination because it is not the actual inclination, it is the inclination of the top view with the XY line, and phi is the actual inclination, that is the inclination of the line with the VP is phi. Here, this is the inclination of the top view with the XY line. So we call beta as the apparent inclination in the top view and alpha as the apparent inclination in the front view. So in these two cases, alpha is greater than or at least equal to beta, theta, and beta is either greater than or at least equal to phi. That is the two conditions. Now how to find out phi and theta as well as the true length when we are given the projections, the actual projections are given. How to find out? Let's see. So here orthographic projections, it means the front view and top view of the line AB with their apparent inclinations, obviously. So here the top view, that is the small letter AB, is not parallel to the XY line, hence its corresponding front view A dash B dash is not showing the true length and the true inclination with HP. So that is when AB, the small letter AB or the top view is parallel to the XY line, then only we will get the true length as well as the true inclination in the front view. So now what we do is we know the front view as well as the top view, then how to find out the true length. So in this case, in order to get the true length, what we do is we rotate the views, rotate the top view so that it will be parallel to the front view, I mean parallel to the XY line. The top view is made parallel to the XY line by rotating the top view. Why doesn't the length of the top view changes when we rotate it? That I will show you how the length of the top view doesn't changes even when the length, the inclination with the VP changes. That I'll show you. But right now you just remember or just take it for granted that when we rotate the line, and we rotate the line in such a way that the line is parallel to XY, the line is made parallel to VP, but the inclination with HP is not changed. The inclination with HP remains the same, and the inclination with the VP is changed, or it is made 0, or it is made parallel to the VP. So this is the condition. This is the condition in which the front view is shown A dash B dash and the top view is AB. And what we do is we rotate the top view. We rotate the top view in such a way that we keep A as the center. We keep A as the center and B is rotated upward in order to make it parallel to XY line. To make it parallel to the XY line. So like this, it is being rotated. Now this length, this new length, I mean new line, the red line. This line will be of length equal to AB. It will be having the same length as AB. Since we are creating a circular arc here, we are rotating it in such a way that A is kept as the center and AB is rotated. So this length will be equal to this length. So that means the length of the top view doesn't changes, and this point we denote it as B1. And corresponding to B1, we find out B1 dash. This point is B1. So AB1 will be of the same length as AB, and B1 we project it to the locus of B dash. So this is B1 dash. Why B1 dash comes at this position itself? This position can be obtained by drawing a horizontal line or a line which is parallel to the XY line. XY line is here. So by drawing a line parallel to the XY line through B dash. And the point of intersection of the vertical projector and this horizontal line. This point is B1 dash. And this horizontal line, that is a horizontal line which is passing through B dash, is known as the locus of B dash. So this line can be denoted as locus of B dash. So when the projector from B1 intersects with the locus of B dash, we obtain the B1 dash. Now we join A dash with B1 dash. Now if you look carefully, A dash B1 dash is the front view and A B1 is the top view. So in this case, A B1 is the top view as well as it is parallel to the XY. The top view is parallel to the XY line. So the front view should be giving you the true length as well as the true inclination with HP, as in the case of the line parallel to VP and inclined at an angle to HP. Since the top view is parallel to the XY line and the front view is inclined at an angle to XY line, this angle should give you the true inclination theta with the xy, I mean HP, the true inclination of the line with the HP. And the length A dash B1 dash should give you the true length of the line, the actual length of the line. Since now the line is parallel to VP and the projection to the and the projection on VP should give you the true length. So that is the condition. So what we do is, if we are given the projections, we rotate the projections or the top view or the front view, so that it makes the view will be parallel to the XY line, like this one. AB1 is now parallel to the XY line, and then we find out the front view also. The same cases, the reverse is also possible. That is, we rotate the front view and make it parallel to the XY line, and in the top view we can find out the true length. That is also possible. And in order to get the true inclination with the VP, that we have to do also. So here it is the true length, and in this sketch, that is in the second sketch, the top view is rotated and made parallel to the XY line, that we have seen. That is, the line is rotated and made parallel to the XY line. Hence, its corresponding front view, A dash B1 dash, is showing the true length and the true inclination with HP. That you have to keep in mind. That is, when the line is making an angle of 0 degree, or the line is parallel to the VP. When the line is parallel to the VP, the front view will give you the true length and the true inclination with the HP. So that is the condition. Now we move on when the true length is known. In this case, we doesn't know. Whatever we have discussed here is the case when we doesn't know the true length. We only know the projections. But when we know the true length, how to determine the top view or the front view, that we have to see. So how to locate front view and top view. The component A2 of true length is drawn, which is further rotated to determine the front view. That is a procedure which is similar to this one, but in the reverse order is what we are doing. See, let's see. This is our VP and the HP, and the XY plane is given. So first we mark the projections of one of the points, say A dash and A. That is the front view as well as the top view of the point A. Then what we do is we draw the true length line, that is A dash B1 dash. Here it is the true length line is A dash B1 dash, and it is making an angle of theta with the XY line, and theta is the true inclination with the HP. So we create this line first. So we draw this line first when the true length is given and the true inclination is given. This line is drawn. Now what we do is we do the same thing in the top view also. In the top view also we do the same thing. That is, here it is the phi, the true inclination with the VP is taken. That is, phi is the angle, and the length AB2. AB2 is the same as the true length, the true length of the line. So AB2 is the true length of the line, and phi is the true inclination with the VP. And theta is the true inclination with HP, and A dash B1 dash is the true length. Now, what we do is we draw a horizontal line through B1 dash, and this line will be the locus of B dash. As I said in the previous case, here a line through B dash, a horizontal line through B dash is passing through B1 dash. So this is the locus of B dash. Same, we are just reversing it, a horizontal line through B1 dash, and this line should be parallel to the XY line, and this line is the locus of B dash. And likewise, we draw the locus of B also. As I said, if B dash and B1 dash lies in the same horizontal line, B and B2 should be lying in the same horizontal line. So here also we draw the locus of B. So here a line through B2 which is parallel to XY is drawn. So that line is the locus of B. So now what we do is we find out the projection of B2. Find out the projection of B2. B2 is projected towards the top, and up to this point we project. So here we denote a point 2. Actually, this is not required in our drawings, but for the easiness of explanation, that point 2 is required. So this portion A2 is equal to, you can find out using the trigonometric relation. Using the trigonometric relation, if you know AB2, the length of AB2 and phi is the true inclination with the VP. Then in that case, you can find out the length A2. And this length A2 is the length of the front view. The length of the front view when the line is inclined at an angle phi with the VP. That we have already discussed. So that can be found out, and the same line is projected, and the same point B2 is projected to this point. This point is obtained through a line by drawing a line passing through A dash, or it can be considered as the locus of A dash also. The locus of by drawing the locus of A dash, and B2 is projected to that particular line. Why this line? Because here we get the true length as well as the true inclination with the VP. In that case, in the front view, the line should be parallel to XY line. That is, in top view, if you have to get the true length and true inclination with the VP, the line should be parallel to HP. If the line is parallel to HP, in that case only in top view you will get the true length and a true inclination with the VP. So here in this particular figure, you have the true inclination, that is phi, and the true length, that is AB2 is the true length. So the front view should be parallel to XY line. So that is why we obtain B2 dash here. So here this point is B2 dash. Now A dash B2 dash is equal to the length of the top view. A dash B2 dash is equal to the length of the top view. But we know that the locus of B dash is here. That is, the actual B dash should be lying in this line. That is in the locus of B dash. So what we do is we rotate A dash B2 dash. We rotate A dash B2 dash with the center as A dash and radius as A dash B2 dash, so that the arc intersects with the locus of B dash. So now this point is B dash. Now finally we join A dash and B dash in order to get the front view. So in order to get the front view, what we do is we first mark the top view of A, and from A we draw a line which is of having length equal to the true length and which is inclined at an angle phi with the XY line. This is corresponding to the XY line, or a line which is parallel to the XY line. So this phi will be equal to the inclination of this AB2 with the XY line, and this phi is the true inclination with the VP. So with an angle which is equal to the true inclination of the line with the VP and the true length, we draw a line AB2, and from B2 we project it to the locus of A dash. The locus of A dash we project the B2. So that point is B2 dash. That is, on the locus of A dash we get B2 dash. And now what we do is we rotate A dash B2 dash such that we will get a point on the locus of B dash, or the point of intersection of the locus of A dash with the arc drawn from B2 dash will give you B dash. So now this is the front view A dash B dash. Now in order to find out the top view of B dash, we know that the front view as well as top view of a single point will be lying in the same projector, in the same vertical line. So what we do is we drop a projector from B dash in order to get it on the locus of B. So that is one method. And the inclination of A dash B dash with the XY line, that is the angle alpha. This angle is same as this angle, alpha. So, and the theta is the true inclination with the XY, sorry, I mean HP. Now, from B dash, we draw the perpendicular projector, and the same point, this point, the point of intersection of this projector with the locus of B, the same point can be obtained in another way. That is actually a checking of what you have drawn is true or not. From A dash B1 dash, we draw or we find the projection of B1 dash on A, the locus of A. So this is the point here. This is the point B1. This point is point B1. I haven't marked it. So that is the point B1. So, and then we rotate the AB1 so that it intersects with the locus of B. So, here is the point B, and this is the way. So, this point is not marked, but this point is B1, this point. So, the importance of that point is when here, in the case of this figure itself, in the front view, the line A dash B1 dash is having the true length, and it is making an angle equal to theta. Theta is the true inclination with the HP. So in the front view, it is giving the true length and true inclination. We know that when the line is, or when the front view is giving you the true length and true inclination, the top view should be parallel to the XY line. So in that case, the top view, AB1 should be parallel to the XY line. Or A dash B1, A dash 1 dash, this line, A dash 1 dash will give you the length of the top view, will give you the length of the top view. So A B1 is same as A dash B1, A dash 1 dash. So A B1 is obtained, and from A B1 we draw an arc, or actually from B1 with the center as A, we draw a circular arc, so that this arc intersects with the locus of B. Locus of B is the horizontal line which is passing through B2. So we obtain this line, this arc, and the point of intersection of this arc with this horizontal line gives you the point B. So AB, join AB in order to get the top view. So this is the complete procedure. If you are given the true length, how to draw it, that is described in here. And if you are given the true inclination, the front view and the top view, how to find out the true length, that is shown here. So these are the two types of questions that is mostly being asked, but there may be a combination of different parameters that will be given, and depending on the number of parameters, on the type of parameters that is given, the drawing will be slightly different. The method of drawing will be slightly different. We will discuss them in our exercises. So in the last figure, A2, here is A and here is 2. So A2 is a component of the true length. It is a component of the true length. And AB2 is the true length, and A2 is a component of AB2, and it gives A2 gives you the front view, the length of the front view. So that length of the front view is brought up A dash B2 dash. It is same as A2. This forms a rectangle. So A dash B2 dash is same as A2. And what we do is we then rotate A dash B2 dash in order to get B dash. So A dash B dash will be the front view. Similarly, by drawing the component of other true length, that is true length in the front view, that is A dash B1 dash, we can get the top view, the length of the top view. So this is the procedure that we adopt when we have the true length as well as the true inclinations. And this is the procedure that we adopt when we have only the projections. So let's go through some of the examples. So before going through the examples, one thing that you have to remember is this figure, this particular figure, this figure you have to keep in mind, or you have to actually by heart it. That is the best thing. This figure, this entire figure, you by heart it. So that based on this particular figure, we will be solving our problems. Most of the problems, I am not saying that 100% of the problems can be solved using only this particular figure, but almost 80 to 90% of the problems related to this particular method of obtaining the projections or obtaining the true length and the true inclinations can be solved using this particular figure. In this figure, actually the front view A dash B dash is given, the top view AB is given, the true length and the true inclinations are given, true length A dash B1 dash is the true length and AB2 is true length, true inclination is theta is there, phi is there, and how to find out the HT and VT, that is also given. HT is obtained by extending the front view A dash B dash to XY line, and that particular point is marked as H dash, and this point is projected to the extension of the top view, and that is point HT. And in order to get the VT, we extend the line, the top view is extended in order to get the point V, and this V is projected to the extension of the line A dash B dash, and that particular point is VT. So almost everything is covered in this here, in this particular figure, and you have to remember this figure. And by the way, this particular method of solving projections of lines is known as the line rotation method. Why it is known as line rotation method? Because we are changing the inclination of the lines with one of the planes in order to make it parallel to the other plane. So in order to make it parallel to one of the planes, we change the inclination with that particular plane, keeping the inclination with the other plane constant. That is, we are keeping theta as constant, that is the inclination with the HP as constant, and then we change the inclination with the VP, so that the inclination with the VP will become parallel to VP, or the line will become parallel to VP. So we are rotating the line. That is why it is known as the line rotation method. So in this particular figure is for the line rotation method only. And there is one more method is available, that is plane rotation method. In plane rotation method, we have to go for another figure. And if you can memorize this particular figure, it is a very simple figure. First you fix A dash and A, then draw AB as well as AB dash, sorry, A dash B dash. B dash and B should be in the same vertical line. Then you draw A, B2, and you find out B2 dash. A dash, B2 dash should be of equal length as A dash, B dash. Just a freehand drawing is enough. B2, then you find out A dash, B1 dash. We locate B1 dash, then A B1 is of the length equal to AB. So this freehand drawing is fully necessary. Now, there are actually 10 important parameters that is to be remembered with the notations. From here onwards, we will be using the same notations, and the same notations are given in the figure also. So, the first things are the true length. True length is TL. We normally denote it as TL, the true length. True length is A dash B1 dash. Here, A dash B1 dash is the true length, as well as A B2 is true length in this figure. Then angle of the true length with the HP. So that is the true inclination with the HP is theta. True inclination with HP is theta. True inclination with the VP is phi, the actual inclination. Then the angle in the front view. In the front view, the angle is alpha. Angle in the top view is beta. Angle in the top view is beta. And the length of the front view. The length of the front view is equal to A dash B dash. A dash B dash is the front view. So the length of the front view is A dash B dash. And that particular value is equal to A dash B2 dash. A dash B2 dash. It is equal to the length of the front view. And the length of the top view, that is AB. AB is the top view. And AB1 is also the length of the top view. AB1 is the length of the top view as well as AB is the length of the top view. And then the position of A, the distance of A from XY line, and the distances of B from XY line. So that is B dash as well as B, the length of B dash and B from XY line, as well as length of A or the distance of A dash and A from XY line is also can also be given. Then the distance between any two projectors. There are actually, we have a number of projectors. This is one, this is the projector for this line. This line is the projector for the horizontal trace. This is the projector for vertical trace. This is projector of A dash, and this is the projector of B dash. So there are 4 projectors. So at least distance between any of these projectors is also a parameter that can be given. So there are a number of parameters, out of which we have classified as only 10. One is the true length, then theta, phi, alpha, beta, length of the front view, length of the top view, then position of A, position of B, and distance between projectors. So there are 10 different types of parameters. And out of all these 10 different types of parameters, only 5 parameters will be given in your question. And using that particular 5 parameters, only using that particular 5 parameters, you have to find out all other parameters. That is our method. And now you just remember, or you just note, and if you remember this particular figure, it will be evident from this one. Alpha and theta. Alpha and theta are constructed based on the point A dash. From A dash, we measure alpha as well as theta. And beta as well as phi, it is based on point A, or it is indexed on point A. And B dash and B1 dash will be on the same locus, that is the locus of B dash. That is, the locus of B dash is a line which is parallel to the XY line, a line which is parallel to the XY line, and both B dash and B1 dash will be lying in the same line. And B and B2 will be lying in the same locus. It is the locus of B. So if we have B or B2, it is easy to draw the locus of B, because drawing a line horizontal to XY line, or a line parallel to the XY line, will give you the locus of B. Once you get B, either B or B2, you can draw the line locus of B. Similarly, if you have B dash or B1 dash, you can draw the locus of B dash. Likewise, if you have one line, you can draw the other one. Another conditions that you have to remember is H dash, VT, A dash and B dash will be on the same line. H dash, VT, A dash and B dash will be on the same line. HT, V, A and B on the same line. So these sort of things, the geometry of this figure, that you must remember. And another condition that you must remember is the true length is never rotated. Only its horizontal component is drawn and it is further rotated to locate the view. We are drawing only the horizontal, or we are finding out only the horizontal component of the true length. Here also, if you consider AB2, we are finding out the horizontal component of that one. So that is A dash B2 dash. In case of the front view, A dash B1 dash, we are finding out the horizontal component of that A dash B1 dash, that is AB. So that way we are finding out only the horizontal component of the true length, and it is never rotated. Only the views are always rotated, and they are made horizontal and further extended to locate theta and phi. The true length is also found out. So this is the figure that you should remember, and why and how this particular line, that is this particular locus of B dash, constitute is parallel to the xy line. How it comes, that we will discuss in a while.